Hello and welcome to another session in physics. In this session we will be looking at the topic magnetism. But before that, let us review the previous lesson. Welcome back. At this point, let's look at what a magnet is and its properties, what makes it up. A magnet is any material that is capable of attracting other pieces of the same material as well as pieces of iron. Now, I'm sure you must have encountered a magnet either before now or sometime in your life. You must have seen what a magnet looks like. But sometimes we have speakers or debris from old spoiled speakers in our houses. When you try to bring metals towards them, they magnet or attract these metals and get them to stick to themselves. We have a substance called lodestone. Now, this lodestone is an iron ore which has the property of attracting pieces of iron substances and is said to be ferromagnetic if it is attracted by a magnet. Examples of substances that can be attracted by a magnet are iron, cobalt, nickel, and certain alloys. Now, some substances which cannot be attracted by a magnet are called non-magnetic materials, and they include things like brass, wood, copper, and glass. Of these things we just mentioned, those that are accessible to you are things like wood and glass. So the next time you see a magnet, to verify this, get a wood or a piece of wood very close to a magnet and see if it gets attracted to it. Or you could get a tumbler or glass and get it close to a magnet, and you'll see that it will not attract the magnet. But get substances such as iron, materials, or certain alloys, and you would see that they would stick to the magnet. At this point, let's look at the properties of a magnet. Now, we have about 4 properties of a magnet. The first we want to talk about has to do with the ends of a magnet, where the attracting power is greatest, and these ends of a magnet are called the poles. We have 2 poles of a magnet. We have the North Pole and we have the South Pole. You can see from the diagram here on the screen, we have the North Pole and we have the South Pole. At the ends of this pole, at these extreme ends, these are where the attracting power of a magnet is greatest. These are where the attracting power of a magnet is greatest. Now, look at this diagram very well. It will give rise to the third point here, which we'll come back to later, that on like poles, north and south will attract each other, but like poles, north and north will repel each other. We'll come to that later. Now, the second property of a magnet goes this way. A bar magnet that is suspended freely in a vertical plane, called a magnetic meridian, comes to rest with its axis in the north-south direction. The part which points northwards is called the north-seeking pole or the North Pole, while the opposite pole has no other option than to be the South Pole. There is nothing like an east or west pole in a magnet. All we have in a magnet are the north and the south poles. So let's not forget this important point. And then the number 3 point, which is actually very important, is that like poles of a magnet repel each other, while unlike poles of a magnet attract each other. Like poles of a magnet repel each other, while unlike poles of a magnet attract each other. Now, the fourth property of a magnet has to do with the polarity of a magnet. The polarity of a magnet simply has to do with the fact that one is north and the other is south. Now, the polarity of a magnet can be tested by bringing both poles in turn nearer to the known pole of a suspended magnet. If 2 of them repel each other, it indicates similar polarity. On the other hand, attraction could be due to 2 unlike poles, or a pole and a piece of unmagnetized material. So, when we bring both poles in turn nearer to the known pole of a magnet, repulsion is the only sure test for polarity. So when they repel each other, it indicates that their polarity is similar. Now let's talk about magnetization and demagnetization. Magnetization, put simply, is a process whereby a material is made to become magnetic. Magnetization is a process where a material is made to become magnetic. And there are a number of methods through which we can achieve this magnetization. Well, we have the electrical method. Now, what does this electrical method entail? Well, a cylindrical coil wound with several tons of insulated copper wire is connected in series with a 6 or 12 volt electric battery and a switch. A coil of this type is what we call a solenoid. Also, a steel bar that is placed inside the coil and the current is switched on for some time. When we remove and test the steel, it will be found to have been magnetized. So basically, we need a solenoid to be able to make a substance become magnetic. A solenoid simply refers to a coil that has been wounded several times cylindrically. That is what we call a solenoid. And then a galvanometer is put in place to test for the presence of an electric charge. Now, in trying to get a magnet, a substance magnetized through the electrical method, it is unnecessary to leave the current for as long as we want. It makes no difference, because if we do that, it can cause overheating and the result will become counterproductive. So the induced polarity depends on the direction of flow of the current and not how long the material has been heated. So if it moves in the clockwise direction, it indicates a south pole, and an anti-clockwise direction indicates a north pole. Now we have another method we use to magnetize a substance, which is called the single touch method. Now look at a steel bar that has been stroked from end to end several times in the same direction with a known pole of a magnet. In between successive strokes, the pole is lifted high above the bar. Otherwise, the magnetism already induced will be weakened. So as it is being stroked at time intervals, it's okay to lift it high above the bar. Otherwise, the magnetism that has been induced will be weakened, so it will become a weak magnet. Now, this method has a disadvantage associated with it. One disadvantage of this method is that it produces magnets in which one pole is nearer the end of the bar than the other pole. So one pole of the magnet is nearer the end of the bar, whereas the other pole can extend maybe up to this point. So we can see from here to here is the south pole, and from here to here is the north pole. So you will see that the region occupied by the south pole is more than that occupied by the north pole. Now let's talk about the divided touch method. This happens when we have a steel bar stroked from the center outward with unlike poles of two magnets simultaneously. And now the polarity induced at the end of the bar where the stroking finishes is of opposite kind to that of the stroking of poles. So this is the divided touch methods, where we stroke two poles of the magnet, two unlike poles simultaneously. Now we also have the hammering method. Magnets can be made by hammering red hot steel bar and allowing it to cool as it lies in the north-south direction. So when you heat a hot steel bar with a hammer, you allow it to cool. As it cools, you would notice in the north-south direction that deflection will take place, which means it is effectively a magnet. Now we also have a way of inducing magnetism in substances. We can do that by getting a piece of unmagnetized steel and bringing it in contact or very near a pole with a magnet, and then when we remove it, it will become magnetized. So when you get a magnet with its pole and then you bring a piece of unmagnetized steel and bring both of them in contact, it results in what we call induced magnetism. Now the induced pole is of opposite sign to that of the inducing pole. So let's say, for instance, this is a magnet and this is the south pole, this is the north pole, and we get a metal and we bring it close here. If this is the south pole, the induced pole here will become a north pole. They are opposite to each other. Alright, demagnetization on the other hand is the opposite of magnetization. So what do we mean by demagnetization? Demagnetization, put simply, is a process whereby a magnet is made to lose its magnetism or its ability to attract objects. One of the ways that we can demagnetize a magnet is through the electrical method. We do that by placing the magnet in a solenoid through which an alternating current is flowing. After a few seconds, of course, the solenoid has to be placed with its axis pointing in the east-west direction, more like this. So after a few seconds, we withdraw the magnet slowly out of the solenoid to a long distance away. Now this is the most efficient method or efficient way of demagnetizing a magnet. We also have the mechanical method, which means we have to point the magnet in the east-west direction as well, and then we hammer it very, very hard. That is the mechanical method. And of course, we have the heating method. When a magnet is strongly heated or introduced to heat, it loses its magnetism. We also have temporary and permanent magnets. Soft iron is a pure iron, while steel is an alloy of iron and carbon. So steel is a much harder and stronger material than soft iron. As a result, steel and iron have different magnetic properties. So iron is easily magnetized than steel, but it readily loses its magnetism. On the other hand, steel produces a stronger magnet, which is the reason why we use steel for making permanent magnets, such as that used in the needle compass. Now, in temporary magnets, we know that the magnetism is required for just a short period of time. We use iron. But when we want a magnet where its magnetism will last for a long period of time, we use steel. Example, electromagnet. Now, let's talk about the magnetic field. Magnetic field, put simply, is a region of space surrounding the magnet in which magnetic force is exerted. Magnetic field, of course, just like every other force field, has its direction represented by magnetic lines. So because of that, we say it is a vector quantity. The direction of the magnetic flux at any point is the direction of the force on a north pole placed at that point. Now, in the neighborhood where two magnets are placed very close together, a magnetic field that changes rapidly is created, and the magnetic flux can be obtained by using iron fillings. When we talk about magnetic meridian at any place, we are talking about a vertical plane containing the magnetic axis of a freely suspended magnet at rest under the action of the Earth's field. The geographical meridian at a place is a plane containing the place and the Earth's axis of rotation. Now, the angle between the magnetic and the geographical meridian is what we call the magnetic meridian. And the angle of dip, or the angle of inclination, is the angle between the direction of the Earth's magnetic flux and the horizontal. Do take time to go through the notes attached at the end of this lesson. Thank you for joining us in this lesson. And to refresh your memory on what we've just discussed, please take the test that will appear on your screen.